Good day, everyone. Today, I would like to share with you some exercises applying the use of integration with the aid of the power formula. Now, to start with, I'm going to share with you the standard formula with the use of the power formula. We have the integral of u raised to n du would be equal to u raised to n plus 1 all over n plus 1 plus a certain constant c. Now, we can only use this formula whenever that your n here is not equal to negative 1. So this is now the integration standard formula in integration with the aid of the power formula. Take note, your n here is your power or simply the exponent of your u. Okay? Okay, let us try to have now sample exercises applying this formula. Let's say, for example, the given is x, the integral of x raised to 5 dx. Okay. Now, for this setup, first, we are going to identify what will be our u. The following should be identified. What will be our u, what will be our n, and what will be our du. Okay? So let's say from the given, you can say here that your u here is x. And after identifying your u, next step is to differentiate or take the du, base it from the given x. If this is your u which is equal to x, then your du is equal to, supposed to be this one is 1 because the derivative of x is 1 dx. However, since this is already 1, so we could just write here dx. Okay. Now, take note that your du here is being represented by du from the given. This is the du, which is exactly the same as this one. In short, we have satisfied this. Now, for your n is equal to 5, and of course, later on, we will be needing the n plus 1. So therefore, your n plus 1 here is equal to 6. Okay, so after identifying all of these things, then we are now ready to integrate the given function. The integral of x raised to 5 dx will now be having a result of here. What is our u? So our u is x, and then what will be our n plus 1? That is here. That is 6, and then another n plus 1, which is 6, plus c. So, in other words, this will now be our final answer. Okay. Now, how do we know whether our answer is correct or not? Now, take note that the result of your integration is already the given in your differential, or the result of your integration is the given of your given differential. Okay, let's try to check this. Okay, let's check. To check this one should correspond to the given x to the 5 or raised to 5. Okay. Let's say if we are going to differentiate your x all over 6 plus c. Now, what will be this one? Now, we know that if we're going to differentiate this will become 6x 5 all over 6. The 6 is there. Plus, of course, the derivative of a constant is 0. So therefore, to simplify this, then we can cancel this and we will only be having the remaining term as x to the 5th or raised to 5, which is exactly x to the 5 is exactly the x of the 5 as you're given. In short, our answer x raised to 6 all over 6 plus c is correct. Okay? Okay, we proceed with the second example. Now, as you can see, we have the given integral of the quantity 3t raised to 3 plus 4 raised to, this quantity is raised to 7 multiplied by t squared dt. Okay, now we could say that this is again an example of the power formula in as much that your your n, I should say, is not equal to -1. So primarily, our u is this. And we will be considering now the remaining part, especially the t squared dt, as your du. Then, but first we have to satisfy whether our du here corresponding to t squared dt would be exactly the du that we are looking for. So what shall we do? Again, always, it would be better for you to make use of the proper procedure identifying first your u. Okay, so considering your u here, we have 3t cubed plus 4. So let's try to have this one as our u. And your du, considering that this is our u, and then our du now will be equal to, differentiating this, we have 3 multiplied by 3 t squared plus the derivative of 4 is 0. Or simply reducing this one, 3 multiplied by 3, that is 9t squared dt. So this is our du. Okay. The question is this 9t squared dt same as from the original? Okay. There is a problem here because on the given, it should be t squared dt. But we'll be coming up with a certain result which is 9t squared dt. In short, we lack 9 there. So we don't have a numerical value containing 9, which is supposed to be, there should be 9. So in order to match or correct this, all we have to do is to have a value of 9 included here. But how do we do that? So that we will not be changing the original equation as is. So to do this, we are going to multiply this one by 1 all over 9. Or simply, let's say for the meantime, let's try to have 9 all over 9. Integral of 3t cubed plus 4 7t squared dt. Okay. Now, since this is 9 all over 9, that 9 here is this one. Anyway, 9 all over 9 here is equivalent to 1. And, of course, that. In short, Even if you are going to multiply and divide this one by 9, the result is 1, and we are not changing the given equation or the function. However, I would like to have it in the form of 1 all over 9 here, and then the 9, I write it there. Then, instead of putting your 9 there, I will just put it here. So that my point here is now to satisfy the 90 squared dt, which is being obtained here. Okay, so from this, we already have a complete dt, yes, complete du, the u, and n. So finally, our u is this, our du is 3, no, our du is 90 squared dt. So therefore, our final answer now will be 1 all over 9. Here, take note, 1 all over 9 here now will be a constant factor to be included. Okay, so we have now your u, which is 3t raised to 3 plus 4. Look at this. Our n plus 1 is, we forgot to include it here. Anyway, later on, if you don't want to include but just satisfy that one by your own, that will be okay. So n here is 7, and then n plus 1 is equal to 8. So therefore here, n plus 1 is equal to 8 all over 8. Okay. And then plus c. There. But if you try to reduce this, we have 1 all over 72. There, 3 t cubed plus 4 raised to 8 plus c. This will now be our final answer. Okay. So that is example number 2. Okay, moving on with example number 3. As you can see it now on the board, we have the integral of second to the fifth x tangent of x dx. Now, our problem here is which of these two functions now will be treated as u. Okay? We can make use of second x as our u. We can also make use of tangent x as our u. As long as we can satisfy the du, then we will not be out from the solution. But so first, let us try to identify our u. Okay? I would like to identify my u to be your second x. And we know that the derivative of second of x, applying derivative here, is second of x. The derivative of second of x is equal to second of x tangent of x dx. Now, what would supposed to be now here my n? So my n here, pay attention because you might be confused basing from the given exponent 5 there. My n is supposed to be now here, or it should be my n to be 4. So from that case, how this happened? Okay, look. The second rate of 5 x tangent of x dx can also be break it down into a form of second to the fourth x, second of x tangent of x dx there. So that my du, basing from here, is that one. So my du there is second of x tangent of x. What I did is break down this 5 into 4, and my exponent here is 1. So if you try to add this together, 4 and 1, still that is 5. However, my form here is useful in determining or identifying that one as my n. So if that would be the case, then we are ready to integrate this. The integral of second to the fifth x tangent of x dx, which is also equal to the second of raised to 4x second of x tangent of x dx, satisfies our condition of u raised to n du. How? My u is second, my du is this, which is exactly this one. And then my n is 4, that is my exponent. Finally, if this will be integrated by the use of power formula, then this will be the result. So u, my u is second of x. My n plus 1 is equal to here, 5 all over 5 plus c. That will just be our answer since n is not equal to negative 1. We did not violate any possible errors there or rule, considering now that this is the given number 3 is also an example of a power formula. So finally, your answer will be this one. Okay? Okay, for example number 4, we have the given here integral of 1/4 ln of w all over w multiplied by dw. Now, whenever the type of integration looks like this, so it would be better for us to rewrite this one in such a manner that the constant will be outside the integral sign like this, and then ln of w all over w dw. Okay, now after this we are ready to determine your u, and then for this given example our u here will be your ln of w, and then of course your du will now be equal to the derivative of ln of w would be equal to 1 all over w multiplied by dw, or you can write it in the form of dw all over w. Okay, and then after that, let us try to identify, by the way, your n. Your n here is, of course, 1. And your n plus 1, naturally, that is equivalent to 2. So therefore, to integrate this one finally, we have here, you have 1/4 there, and then the derivative, the integral of ln, we are applying your u raised to n du is now equal to, our u is of course ln of w. Our n plus 1 will be, we have 2 all over 2 plus c. And this will reduce into, since that is 1/4 multiplied by 2, then final answer now will be your 1/8 ln of w squared plus c. So this will be our final answer for example number 4. Okay. So guys, those are some examples that I could share with you, and hope you're able to understand the principle with the aid and the use of the integration under the power formula method. So take note You can only make use of the power formula if ever that there is a certain exponent raised by a certain given u, like this. And another important thing that you have to consider is that your n here should not be equal to -1, so that you can apply your integration with the use of the power formula. So with that, thank you very much, and hope you can now work with some of the activities later on that will be assigned to do so. Have a good day.